Welcome students, this is the fourth class of sequential circuits. In the last three classes we discussed different latches and flip-flops. In the last class we discussed about NOR based and NAND based SR flip-flop. Okay, and we designed a synchronous circuit. That means the clock basically decides when the output will change. So the operation is synchronous with the clock pulse. Now we also study the timing diagram of SR flip-flop. Okay. Now we'll study about a new flip-flop that is called delay flip-flop or D flip-flop. What is that? That is nothing but it is a derived from the NAND based SR latch, where we sort the S input and R input. Let me show that this is the S input and this is the R input. Okay, so we sort these two inputs through a NAND gate, and this input is called D input and the output is Q1. So this flip-flop is basically called delay flip-flop or D flip-flop. What is the characteristics table? If I make D equal to 0, suppose the present state is 0, the next state will be 0. If I make D equal to 1, if the present state is 0, next state will be 1. That means if I make D equal to 0, output will be 0. If I make D equal to 1, output will be 1. Okay, so this is the characteristics table and is a symbol of a D flip-flop. Now, in the next section, we will discuss a new flip-flop which is basically called JK flip-flop. What is that? What is JK flip-flop? Let's come to the diagram. This is a NOR based implementation and this is a NAND based implementation. We'll study this NAND based implementation first. Okay. Now what is that? Again we see this is just modification of the previous NAND based SR flip-flop. Here we connected one connection from Q bar to this gate, okay, and another feedback connection from Q to this gate. So here this is the clock signal. Okay, so this is J and K. The new input is called J and K, and this section is nothing but a NAND based SR latch. Okay, so let's study what will be the circuit operation for that. And this is the characteristics table. This table is called characteristics table. Now, according to this characteristics table, if we see in detail that if J and K both are 0, the output will not change. That means if the output is 0, it will remain 0 in the next step. If the present output is 1, the next output will be 1. Now, so this is called a no change condition. This is called no change condition when J and K both are 0. When J equal to 0 and K equal to 1, this is called the reset state, because see that whatever be the present state, the next state will be 0, 0. This is the present state, this is the next state. So this is called reset condition or reset state. If we apply J equal to 1 and K equal to 0, whatever be the present state, the next state will be 1, 1. Okay, so that is called set state. So it is completely same with NAND based SR flip-flop. Okay, the operating principle also same. Now look into this. We have seen that that NAND based SR latch, SR flip-flop, if we set S equal to 1 and R equal to 1, the state will be invalid. Then means the next present state and next state, this state will be invalid. So, but here we see we solved that invalid state problem here. What is that? If I set j equal to and k equal to 1, if the present state is 0, the next state will be 1. If the present state is 1, next state will be 0. So that is the modification from the previous design. In the previous design, that means in NAND based SR flip-flop, the 1-1 conditions are invalid, but here in JK flip-flop, the 1-1 condition is not invalid. This new state is called basically toggle state. That means the inputs are toggling from 0 to 1 or 1 to 0. Okay, so this is called toggle state. The new state which we can see in JK flip-flop only. So I'll explain the operation now of the circuit, that how this basically toggles. Let me go back to the circuit diagram. Now, okay, first of all, take the pencil. Yes. Now, if I set both is equal to 1, j equal to 1 and k is also equal to 1. Okay, I'll say q is 0 and obviously the q bar is 1. Okay, so what is the inputs here? This input is 1, this input is also 1 because it is a clock is high, and this input is basically connected from here, so this input is also 1 because q bar is 1. So all the inputs are 1, so output of this gate will be 0 according to NAND gate operation. And this also, this is 1, this is 1, this is 0 because it is connected from the q bar, so the output is 1. Okay, so this is the S is equal to 0 and R is equal to 1, and we have already seen that in case of NAND based SR latch, if I set S equal to 0, output will be 1. If I set S equal to 0, output will be 1. Let's check. So this is 1, so this 1 will come here, so 0 1, that means the output will be 1. Okay, so output will change to 1. Now if this is 1, so this 1 will come here. Now this is 1 1, so output will be 0. Okay, so it is very clear that if I set j equal to 1, k equal to 1, in this new design, means in JK flip-flop, it is not invalid now. It is just toggling from 0 to 1 and from 1 to 0. Okay, so this is the new state. Okay, and the rest of the operation, that means for no change condition, for set condition, for reset condition, all the operation is just similar with NAND flip-flop, NAND based SR flip-flop. Okay, so in this new design, in this JK flip-flop, we basically solved the invalid state condition, and we introduce a new condition of flip-flop, that is called toggle. So this is the upgradation from the previous design, but in this design we have some problem also. In the next class we will discuss what is the problem of this design and how we can remove this problem, and how we can modify this circuit and we can remove this problem. Okay, so in the next class we will discuss all this. Thank you, students.